Welcome to a review video for Math8A, where we are going to go over the Chapter 7 practice test. So we have a Chapter 7 test on exponents and exponential functions coming up, and we are going to review this practice test problem by problem by problem, as I always tell you on these videos. I'm going to give you the answers to all these problems. After that, feel free to fast forward to the parts where I explain the problems that you need help with. You can skip the parts that you don't need help with. You can rewind, move back, move forward. You don't have to watch this whole entire video. Just watch the parts that you need to watch in order to help you be ready to take a test on this stuff, because you're going to have to. So here we go. Here is the answer key for this practice test. You can pause this video and take a look at these first 9 answers. And then there's 10, 11, and 12 as well. On these problems that say or, I'm okay with you expressing your answer in either different way, and since this is going to be a handwritten test, not typing into Edulastic, you don't have to worry about formatting it incorrectly. You can give me it in either format, and that's totally fine. Here's the back side. Number 13, 14, 15, 16, and 17. By the way, on number 16, the graph is worth 1 point. The y-intercept is worth 1 point, and the domain and the range together are worth 1 point. So this problem, number 16, is worth 3 points. Okie doke. Then number 18, $14,797.81. And with those extra points on number 16, that brings the total on this to a score out of 20. So you can give yourself a % out of 20 and see how you did on this practice test. Hopefully you did well, but if there's anything you missed, let's talk about it. Here we go. So we're going to go problem by problem by problem through this practice test. And figure out how we can get these all right. Remember, what we have said many times in Unit 7 and Chapter 7 is, when in doubt, write it out. So I could do that on this. But honestly, do I need to do that? If I did that, how many D's would I write out? I'd write out 11 D's, and then I'd write 9 more D's. Wouldn't I write 20 D's? Okay, so what we want to remember here is all you got to do is add the 2 exponents to get your new exponent in this kind of situation. But feel free to, when in doubt, write it out if you need to double check your process. All right. On number 2, similarly, I could, when in doubt, write it out. When I cube something, that means I'm going to do it times itself times itself. And then I could, when in doubt, write it out even more and write out all the W's and write out all the Y's, but I think you can see that I would have 5, 10, 15 W's and 4, 8, 12 Y's here. And as you know, the trick on this one is, what do you do with these exponents? You multiply them. 3 times 5 is 15, 3 times 4 is 12. That's the easiest way to get your answer. Nice and short and quick and easy. All right, on number 3, it's just a multiplication problem. You just got to multiply everything together. So I would say that this is 9 times t times t times t times, oh boy, a bunch of n's. Then times a -2 times another t, just 1, times a couple of more n's, and yeah, okay, I didn't need to write this all out, but just to show you, 9 times -2 is -18. How many t's do I have? 4. How many n's do I have? 5, and then 2 more is 7. -18 t to the 4th n to the 7th is what we should get there. Okay, again, on number 4, I could, when in doubt, write it out. And I could write 20 x's. Please, no, I don't want to write 20 x's. I could if I needed to, right? Persevere if you need to. But basically what's going to happen is the 4 x's on the bottom are going to match and scratch, right? Remember match, scratch, match, scratch, match, scratch, match, scratch. And how many other x's would I have here? Well, I had 20 and I took 4 of them away. Oh wait, 20 take away 4. What do I do with the 2 exponents here? I just subtract. So 20 minus 4 is 16. All you got to do is subtract on that problem. No problemo. Okay, on number 5, before you do anything else, you're going to have to square the top and cube the bottom. Okay, before you do anything else on number 5, square the top and cube the bottom and rewrite this whole thing. So square the -8. What's -8 times -8? Positive 64. Square the x squared. That's x to the 2 times 2. Square that y squared. So that's y to the 4th power. Then I'm going to cube the bottom. I'm going to cube the bottom of this. So I'm going to do 4 cubed. That's 4 times 4 times 4, which happens to also be 64, interestingly enough. Cube the x cubed, so that's x to the 3 times 3. And then y to the 3, y cubed, yeah? And then now I'm going to just realize that 64 divided by 64 is 1. Those are gone. It's going to be x to the 4 minus 9, which is 5. And then y to the 4 minus 3, which is 1. And you don't even have to write the 1. So I could say, oh wait, 4 minus 9 isn't 5. 4 minus 9 is -5. So this is going to be x to the -5y. And you could write the little 1 here if you want to. Or, what does a negative exponent mean? It means that there was more x's in the bottom than there were in the top. And these 4 are going to cancel 4 of those 9 out, and there's 5 in the bottom now. So I could write it as a y on the top, because there's 1 y more on the top than there is on the bottom, right? A y on the top, and then 5 x's on the bottom. Y over x to the 5th. Either one of those is an okay way to write your answer on this. Okay, on number 6, 16 divided by 4 is 4. That part is pretty straightforward. R is going to be r to the 3 minus -1. What's 3 minus -1? 4. So it's 4r to the 4th. And then t is going to be -5 minus 2, right? -5 minus 2, because you subtract those 2 exponents. So that's t to the -7. And you can write it like that, or if you want to write it fractiony style, that tells you that there's a 4r to the 4th on top, and then a t to the 7th on the bottom. There's 7 t's on the bottom of that. Or you could even, if you wanted to, write it with a 4 in the front, and then an r to the 4th and a t to the 7 on the bottom. I guess they're all just different ways of writing the same thing. Okay, so those are some basic exponent problems there. Now we're going to solve. So whenever you see on 7, 8, 9, and 10, where it says solve, anytime the directions say solve, I know what I'm looking for is what does x equal. Oh, what does x equal? Oh, I better remember to write the x equals, because that's what I'm trying to figure out. What does this x equal? What does that equal? What does that x equal? Okay, so for number 7, this is just a calculator problem. You just have to figure out how many 11s it takes to get to that number. So 11 to the 5th power? Nope, not big enough. 11 to the 6th power? Yay, I found it. So I just made a, couple good guesses until I found it. you could have figured out that. And so what must x be? X must be 6 because 11 to the 6th power equals that. Okay, so that was the easy version of this kind of problem. Then we get to a harder version of this kind of problem. 36 isn't a power of 6. 6 is a power of 36. But I could write 36 as a power of 6, right? Did I say that right? Maybe that was confusing. Let me try this again. 6 isn't a power of 36. 36 is a power of 6. So what I want to do on this one is I want to rewrite 36 as 6 squared, because isn't that what 36 is? 6 squared? So I could say this to the x minus 2 is this to the x minus 2. And I could rewrite the equation like that with the invisible 1. And if I have this, then it must be that all of this equals this, because if 6 to that equals 6 to that, then this must equal that, right? By the way, why did I put 2 parentheses x minus 2? Because that's what you do with exponents in this situation. Don't you multiply them when there's parentheses? So 2 times x minus 2 must equal 1, and now we just need to solve that equation for x. So you can distribute 2x minus 4 equals 1. Add 4 to both sides. Oh, I'm going to get 5 divided by 2. I could say my answer is 5/2, or I could call it 2.5, or I could call it 2.5, or however else you want to say that. Okay, no problem, easy enough. Number 9, same idea here. I want to write 256 as 4 to the something. So that's where my calculator comes in. I don't know off the top of my head what that is, so I'm just going to try something. How about 4 to the 8th? Way too big. How about 4 to the 6th? Too big. Whoops. 4 to the 5th? Too big. 4 cubed? Wait a second. Uh-oh. Shoot. 4 cubed is 64. 4 to the 4th is... Oh, there it is. How did I skip that one? 4 to the 4th. I found it. Yay me. 4 to the 4th equals 4 to the 3rd. Oh, wait. So 3x minus 2 must equal 4. If 4 to this equals 4 to that, then this must equal that. Just, right? Yeah, substitution idea here. So, again, just solving an equation. This one comes out a little bit cleaner. And you get x equals 2. And then, same idea on number 10. I got to figure out 32 is 2 to the what power, so I'm just going to try 2 to the 9th power. Nope, too big. 2 to the 6th power. Too big. 2 to the 5th power. There it is. So 32 is 2 to the 5th power. So I'm going to make this 2 to the 5th power to the x plus 3, right? Instead of 32 to the x plus 3 equals 2, and I'll put 2 to the 1 to the 1th. To the power of 1, and I'm just going to make this an equation. What do I do with the 5 and the x minus 3? I'm going to multiply them. So 5 times x plus 3 equals 1. 5 times x plus 3 equals 1. So 5x plus 15 equals 1. Take away 15. Negative 14. Oh boy. I'm going to get negative 14/5 on this one. And that's okay. It doesn't mean I did anything wrong. That's the truth. X does equal negative 14/5. And if you're not sure if that's correct, could you plug that number right here and then add 3 and then use your calculator? Let's do that. Negative 2.8 plus 3. Negative 2.8 plus 3 is 0.2. And let's see if 32 to the 0.2 power is 2. It is. Now I know I got it right. Yay for me. I feel good. And you should too. All right. Number 11 and number 12. Fractiony exponents. Fractiony exponents mean roots. Okay, what kind of roots? If it's a sixths, then it's a sixth root. Sixth root of what? 64 to the fifth. Oh boy, does that mean I really have to do 64 times 64 times 64 times 64 times 64? Well, maybe not. You could unsixth the 64 first and then do that to the fifth. You can do it in this order, or you can do it in this order. You can root the 64 and then fifth power it, or you can fifth power it and then root it. Either way, that's basically calculator work for you. Your calculator will do that work for you, and what ends up happening is you get 32 out of that, because the sixth root of 64 is 2, and 2 to the fifth is 32. Or 64 to the fifth is some gigantic number, and when you sixth root that gigantic number, you get 2. So you'll get it either way. All right, what does that mean about number 12? Again, very similar. I'm going to do the fourth root of 81, and then I'm going to do that to the fifth, or I'm going to do 81 to the fifth and then fourth root it. Doesn't really matter which order you go. I like to do the root first. The fourth root of 81 happens to be 3, so this happens to be 3 to the fifth power, and that comes out to 243. Again, your calculator is going to be very, 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 very helpful. So triple underline, triple exclamation point, double star, bring a calculator. You're going to be in a world of hurt if you don't have a calculator with you on the Chapter 7 test. All right, that's the front side. Here's the back side. Number 13 and number 14, you don't have to solve anything or do anything. All you have to do is just rewrite something. Just rewrite something. So what does a fraction exponent mean? It means a root. What kind of root? If the bottom is a 3, then that means it's a third root of 22. Cube root of 22. Easy. Just, right? Almost a freebie. You just have to know how to do that. Okay, so that's your trick. On number 14, there's a little catch here. It's a fourth root. But what's getting fourth rooted? Is the 3 getting fourth rooted? Is the x getting fourth rooted? Both? Only the x is getting fourth rooted. There's no parentheses or anything. So the 3 is just a 3, and it's getting multiplied by the fourth root of x. So it's really 3 and then the fourth root of x. Don't put the 3 inside the radical. Don't put the 3 inside the radical. The only time you would put the 3 inside the radical on this one is if the problem had had parentheses. Then you would have done this. But it didn't, so you shouldn't. Okay, number 15. A weightlifter can bench, blah, 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 blah. Who cares? All that you really need to do is hone in on this little piece of information and then plug in a 4, right? I mean, yeah. So how are we going to do that? I'm going to do the 1.05 to the fourth power first. Then I'm going to hit times 165, and boom, there's my answer. It's about 201 pounds, right? You could say 200.6 pounds or 201 pounds, however you want to say it. Roughly 201 pounds, or 200.558, whatever, ... Okay, just a calculator problem. Again, bring a calculator. You're going to need one. You're going to be mad if you don't have one. Number 16, 3-point problem here. 3-point problem. So 1 point for the graph, 1 point for the y-intercept, 1 point for the domain and range. Let's find the y-intercept first. The y-intercept is what you get out when you put in a 0. For any function, the y-intercept is what you get out when you put a 0 in for x. So What's 7 to the 0 power? The same as anything to the 0 power, 1. So the first thing we're going to do on our graph is get a dot right there at 1. All right, so we got the y-intercept right. We know that this graph is going to go through this point. Where else is the graph going to go? Well, if your function is y to this equals 7 to the x power, is 7 to the something power always going to be something? Yes. Is it ever going to be 0? No. So what I would like to see on your graph is either you draw the little asymptote, you draw the little boundary line, or at least make sure that your graph never, ever, ever, ever touches the x-axis, because it's going to go like this, and then it's going to get real tall real quick. In fact, we know that if you put in a 1, you'd get out a 7. So actually mine wasn't quite steep enough. It should have gone through that. But I don't really care about the artistic merit of your graph. What am I looking for? I want to see that your line doesn't cross the boundary. I want to see that the y-intercept is in the right place. And I want to make sure that if it's supposed to go up, 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 it goes up, up, up. And if it was one of these where it's going to go down, 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 make sure that it goes down, right, if it was supposed to. On this one, it wasn't supposed to, but yeah. And then tell me about the domain and range. What can you plug in? For the domain, all real numbers. Right? There's no number that you can't put in for x. X could be anything. But what can I get out? What can I get out? Am I ever going to get a 0 out of this function? Nope, it's always going to be 7 to the something. It's always going to be something. Am I ever going to get a negative number out of this function? Nope. Y will always be positive. Y will always be greater than 0. That is the range and the domain of this function. No problem. We can handle that. All right, just make sure you're clear on that, because that's 3 out of the 20 points. That's 15% of this test grade. Okay, number 17 and number 18. Okay, number 17, the amount of an investment is 700. That's my starting number. 1 plus. We're always going to do 1 plus. 8% is 0.08. Compounded monthly, that's a 12, is my n. And I'm going to put that number here for 9 years, right? And then just let your calculator do the work. Just let your calculator do the work. I'll do it real quick for you. Here's how I would do it on my calculator. 0.08 divided by 12, I'd do that first. Then I'd add 1. So I did all this part, and I know what that is. I'm going to do that to the 12 times 9 power. So I'm going to hit to the, and I can even do on my calculator, I can even do that. Yeah? And then times 700. Wait a second, I did something wrong there. Scratch that, rewind, pretend like I didn't just say that. Okay, 0.08 divided by 12 plus 1. Okay, that's what this inside number is. To the 12 times 9 power, that's where I went wrong last time. This, and I have to go like this, 12 times 9. That's what I have to do. Equals, okay, then times 700. I just wanted to show you the wrong way before I showed you the right way. All right, so that's your answer, and it's in money, so you're going to say it's $1,434.67. Just round to the nearest penny since we're talking about money. Last one. Depreciation means things are going down in value. So it's going to start at 38,000, and I'm going to put 1 minus, right? Minus, because it's depreciating. 9% is 10 years. Boom. Yeah, that's all I got to do. So 1 minus 0.09. Oh yeah, if it loses 9%, then it's going to have 91% left. So it's going to be 91% to the 10th power, because it's 10 years. Get that? Times it by 38,000. And boom, there's my answer, 14,000. It lost more, over half its value in those 10 years. That's what happens in life. Things depreciate. Sorry. Okay, that's it. Hope this helped. Good luck on the test. See you next time.